To err is human, but when science errs, the whole world feels it. After all, science is supposed to be our best shot at getting things right. But since scientists are human, well, most of them, mistakes happen. And sometimes, those mistakes are pretty embarrassing. Take the recent hype about life on Venus. Scientists thought they had found phosphine, a gas supposedly linked to life. But upon closer review, that evidence started looking shaky. While the final verdict is still pending, history is full of scientific missteps just like this, where bold claims turned out to be flat out wrong. We're not talking about fraud or wild theories, just major conclusions that got tons of attention before ultimately getting debunked. Here are 15 of the most infamous ones. Number 15. Age of the universe. When astronomers discovered that the universe was expanding in the late 1920s, they naturally wondered how long it had been doing so. By measuring the expansion rate and extrapolating backward, they concluded that the universe must be less than 2 billion years old. There was just one glaring issue. By this time, radioactive dating had already confirmed that Earth itself was much older. It was absurd to think that the universe could be younger than our own planet. The mistake came from how distances were measured. Astronomers relied on Cepheid variable stars, which pulsate in brightness. The issue? Well, much like different sorts of light bulbs, Cepheids have different brightness levels, which weren't accounted for, leading to an incorrect expansion rate. Once astronomers corrected this mistake, they recalculated the true age of the universe. Today, multiple methods converge on an age of 13.8 billion years, but it is really true? Number 14. Neutrinos faster than light. Neutrinos are tiny, almost massless subatomic particles that barely interact with anything. They're fast, but not faster than light. Yet in 2011, scientists at CERN reported something unbelievable. Neutrinos sent from Switzerland to Italy arrived 60 nanoseconds earlier than a beam of light would have. If true, this would mean Einstein's theory of relativity was wrong, a claim that, if confirmed, would rewrite modern physics. The announcement made global headlines, but most physicists were skeptical. The numbers were shocking, but something felt off. Scientists urged further investigation before drawing conclusions. Sure enough, in 2012, the team found the real culprit. A loose fiber optic cable had thrown off the timing system, creating an error in the calculations. Einstein's relativity remained intact, and neutrinos stayed within their expected speed limits. The incident became a perfect example of why scientific skepticism and careful verification are crucial, especially when claims challenge the fundamental laws of physics. Number 13. Gravitational waves from the early universe. For years, scientists have been hunting for clues about the universe's earliest moments, and one of the biggest targets has been primordial gravitational waves, ripples in space-time from the Big Bang itself. According to the inflation theory, these waves should have left faint imprints on the cosmic microwave background, the afterglow of the Big Bang. Then came 2014, when a group of scientists thought they had finally found them. Their telescope, BICEP-2, detected precisely the signal they expected, seemingly proving both inflation theory and confirming Einstein's general relativity once again. The scientific world went wild. The problem? The signal was much stronger than the theory predicted. Turns out, their data had been contaminated. Cosmic dust in our galaxy had mimicked the effect they were looking for. So, while we've since detected gravitational waves from colliding black holes, the earliest ones from the dawn of the universe remain elusive. Science, as always, marches on, and it can't be always true. Number 12. Recapitulation theory. Before Charles Darwin's theory of evolution revolutionized biology, scientists explored alternative ideas to explain human development. One of these was recapitulation theory, proposed by Johann Friedrich Meckel, who believed that human embryos went through various evolutionary stages, briefly resembling less perfect species like fish. His idea stemmed from the observation that embryos had gill-like slits, leading to the conclusion that humans essentially relived evolution in the womb. Later research confirmed that human embryos do have gill-like structures, but they are not actually functional gills. Instead, they are pharyngeal arches, which eventually develop into parts of the face, jaw, and throat. The idea that humans pass through fish, reptiles, and other evolutionary stages was ultimately disproven. Despite being discarded, recapitulation theory contributed to our understanding of embryology and evolutionary biology. It remains an example of how early scientists, while often wrong, helped lay the groundwork for more accurate scientific discoveries. Number 11. Humoral theory. For nearly 2,000 years, medical science was dominated by humoral theory, a belief that the human body's health depended on maintaining a balance of 4 bodily fluids: blood, yellow bile, choler, black bile, and phlegm. This concept, heavily influenced by Hippocrates and Galen, shaped both Western and Eastern medicine for centuries. Each humor was thought to correspond to a personality type. Sanguine individuals were seen as cheerful and energetic, phlegmatics as calm but sluggish, choleric as fiery and aggressive, and melancholics as sad but often creative. Treatments were based on adjusting humoral imbalances, leading to bizarre medical practices like bloodletting, induced vomiting, and dietary restrictions. With progress in anatomy, microbiology, and germ theory, humoral medicine was abandoned in favor of evidence-based medicine. While the theory was scientifically flawed, it provided an early framework for understanding human health and disease, influencing the development of modern medical diagnostics. Number 10. The Age of Earth. How old is Earth? Today we know it's about 4.5 billion years old, but back in the 18th and 19th centuries, things were a lot messier. In the 1700s, Georges-Louis Leclerc, Comte de Buffon, estimated Earth's age at 75,000 years, a number that already seemed large at the time. By the 1800s, geologists and biologists, including Charles Darwin, were arguing for an age in the hundreds of millions to allow for slow geological changes and evolution. Enter Lord Kelvin, a legendary physicist. In the late 19th century, he used thermodynamics to calculate Earth's age based on how long it would take a molten planet to cool. His answer? Well, it's pretty good. No more than 100 million years, and possibly much less. His logic seemed airtight. But there was one problem: radioactivity. Scientists haven't discovered yet that radioactive elements generate heat, significantly slowing Earth's cooling process. Once radiometric dating was developed, Kelvin's estimate was thrown out the window. Earth was billions, not millions, of years old. Number 9. Earth in the middle. In one of the most well-known and long-lasting scientific misconceptions, astronomers once believed that Earth sat at the center of the universe. And for that, we can mostly blame Aristotle. He wasn't the first to propose a geocentric model, but he was the one who argued that it was incontrovertibly true. His reasoning? The element Earth naturally moved toward the center of the cosmos, so Earth must be there. The logic may have sounded convincing at the time, but it was deeply flawed. For centuries, this idea remained unchallenged. Then, in 1543, Copernicus made a strong case for a heliocentric model, with the sun at the center. Even then, skepticism persisted. But in 1610, Galileo made a breakthrough. His telescope revealed that Venus went through a full set of phases, something that could only happen if it orbited the sun. That discovery finally disproved the geocentric model. It took centuries to correct, but this mistake perfectly illustrates why science, unlike dogma, corrects itself, eventually. All right, now, let's move to Number 8. Eugenics. Eugenics is one of the darkest chapters in scientific history, an ideology that falsely claimed that the human population could be improved through selective breeding. The idea was that certain races and ethnic groups were superior, while others were deemed unfit and needed to be eliminated through forced sterilization, segregation, and social exclusion. In the 19th and early 20th centuries, eugenics was not a fringe belief. It was widely accepted by scientists, politicians, and even leading academics. The movement gained traction in Europe and the United States, leading to sterilization laws targeting marginalized communities, people with disabilities, and minority groups. This pseudoscience later influenced the horrific racial policies of Nazi Germany. By the mid-20th century, eugenics was thoroughly debunked, as genetics proved that intelligence, behavior, and social standing are not determined by race. Today, it is recognized as scientific racism, an example of how misuse of science can lead to destruction. Number 7. The tongue map. For decades, students were taught that the tongue is divided into different taste zones, each detecting only one of the 5 tastes: sweet, sour, salty, bitter, and umami. This tongue map theory, originally proposed in the early 1900s, suggested that specific regions of the tongue were responsible for specific tastes. The problem? It was completely wrong. Modern research has confirmed that taste receptors are spread evenly across the tongue, meaning no single area is dedicated to detecting only one type of taste. While certain regions may be slightly more sensitive to specific flavors, every part of the tongue can detect all 5 tastes. The persistence of the tongue map was largely due to a mistranslation of an early study, which led to its widespread adoption in textbooks and classrooms. Today, the theory is fully debunked, serving as a reminder that scientific misconceptions can persist for generations before being corrected. Number 6. Cold fusion. In 1989, scientists Stanley Ponce and Martin Fleischmann made headlines when they claimed to have achieved cold fusion, a nuclear reaction occurring at room temperature, producing massive amounts of energy with minimal waste. If true, this would have been one of the biggest breakthroughs in history, offering an unlimited clean energy source. The claims sparked global excitement, with researchers around the world rushing to replicate the experiment. However, no one could reproduce the results. Critics pointed out flaws in the methodology, and further analysis revealed that the excess heat observed was likely due to experimental errors. By the early 1990s, cold fusion was widely dismissed as bad science, and Ponce and Fleischmann's reputations suffered. While nuclear fusion is still an active field of research, achieving it at room temperature remains an unproven dream. This case became a classic example of why peer review and reproducibility are essential in scientific discoveries. So, always check while drinking. Number 5. A weird form of life. A 2010 report claimed that scientists had discovered an organism that replaced phosphorus with arsenic in its biological molecules, a finding that, if true, would completely rewrite biology. Life as we know it requires phosphorus, but this study suggested that arsenic could take its place, hinting at entirely new possibilities for alien life. At first, the evidence seemed promising, and even NASA backed the findings, sparking worldwide excitement. However, skepticism was high, and scientists quickly began testing the results. Upon closer examination, they found that the bacteria weren't actually using arsenic to build their DNA. They were merely tolerating it. The initial study had a flawed methodology, and follow-up research debunked the claim. This discovery never made it into textbooks, but it became a reminder of why science demands rigorous testing. Even the most exciting breakthroughs can collapse under scrutiny, and it's true. Number 4. A weird form of water. In the 1960s, Soviet scientists made a bold claim. They had discovered a new form of water. This strange substance, called polywater, had bizarre properties. It was denser, more viscous, and had unusual boiling and freezing points. It seemed that water molecules had somehow bonded uniquely, creating a completely different substance from regular water. Excitement spread rapidly. Chemists around the world rushed to study polywater, thinking it could lead to groundbreaking discoveries in physics and chemistry. But as research continued, doubts emerged. Soon, experiments revealed the truth. Polywater wasn't a new form of water at all. Instead, the strange properties were caused by impurities that had contaminated the samples, mainly from the narrow tubes used in the experiments. By the early 1970s, polywater had been completely debunked. It became a classic example of why extraordinary claims require extraordinary evidence, reminding scientists to always question even the most exciting finds. Number 3. A one-galaxy universe. Imagine a time when astronomers thought the Milky Way was the entire universe. Hard to believe, right? Yet in the early 1900s, this was the dominant belief. Those beautiful, swirling spiral nebulae? Scientists thought they were just gas clouds inside our galaxy. Then came Edwin Hubble in 1924. Using a telescope at Mount Wilson Observatory, he studied a star in the Andromeda Nebula and realized it was way too far to be inside the Milky Way. That meant Andromeda wasn't just a nebula, it was a whole separate galaxy. So, what went wrong before Hubble? Astronomers had measured internal motions within these nebulae, believing that if they were really far away, those motions wouldn't be visible. But their calculations were flawed. The result? A massive shift in our understanding of the cosmos, and the realization that our universe is far, far bigger than we once thought, and we can never understand or measure it. Number 2. A supernova's superfast pulsar. When a supernova exploded in 1987 in the Large Magellanic Cloud, astronomers expected to find a pulsar, a rapidly spinning neutron star left behind after the explosion. But nothing showed up. Then, in January 1989, a radio telescope suddenly picked up a repeating signal, nearly 2,000 pulses per second, far faster than any known pulsar. For one night, scientists believed they had discovered something new, an ultra-fast pulsar. But then, just as suddenly as it appeared, the signal vanished. Cue frantic theorizing. Could it be a pulsar that self-destructed? A new, unknown astrophysical phenomenon? Nope. The answer came in 1990 when a telescope technician adjusted the guide camera and, surprise, the signal returned from a completely different supernova remnant. Turns out the pulsar had never existed. It was just electronic interference in the telescope's guiding system. Science fails like royal kings. Number 1. A planet orbiting a pulsar. In 1991, astronomers thought they had found one of the first confirmed exoplanets, and around a pulsar, no less. The pulsar, located 10,000 light-years away, showed irregular radio pulses, suggesting it had a companion planet orbiting it every 6 months. The discovery made headlines. A planet orbiting a pulsar would be mind-blowing. How could a planet survive such a violent environment? But soon, the excitement turned to embarrassment. The team realized they had made a critical mistake. They had used an imprecise value for the pulsar's position, and the irregularity in the pulses wasn't caused by a planet at all. It was just an effect of Earth's own motion around the sun. While planets have since been confirmed around pulsars, this particular one never existed. A classic case of science jumping the gun. If you have enjoyed this video, be sure to like, share, and subscribe. Thanks for tuning in, and we'll see you soon in the next one.